Hello guys, today I'm bringing another Cisco Modeling Labs lab, which is going to be pretty straightforward. It's a layer 3 base lab, right? We are going to apply, some IGP concepts and EGP concepts as well, such as, you know, OSPF and EIGRP, also as PGP for routing protocols. We're also applying some a little bit of policy-based routing right here, and of course NATing and padding uh, for private address translation. And we're also gonna like have some public subnets in each of the networks for us to advertise it, over EBGP, and we of course will make sure that public subnets are reachable in the neighboring autonomous system, and of course that there's no any private subnet leaking from one AS to the other AS. And yeah, so not saying much, let's start walking through the lab. Okay, so now let's start with the first autonomous system, the AS4048, which will be based on OSPF, right? And first, I want to, of course, and mention and explain the reason of network design like this. So basically, mainly in the core, in the area zero, in the backbone area, right? I place a switch right here in the middle because I want to use put, and of course, the concept of broadcast, the OSPF broadcast type, right? In contrast of having a point-to-point connection and others. And yeah, so I decided to make the area zero like that, spanning the backbone area and these routers, they go to these routers, and having a second area, area one, connecting to the backbone area, and via an area border router right here, and making a point-to-point connection with another router, which will be completely, internal from area one. Okay, so let's take a quick look to the OSPF domain and this autonomous system. And we go to router 2, we can confirm the point-to-point network type that we have right here in area 1, right? Let's just see right here. So we have right here that we're advertising, of course, it's an area border router, so we're advertising both the the subnet on area zero as well as the subnet on area one, right? And we have right here to configure this facing side as a network type, point to point for the OSPF link to area one, as well as we did it on this side on this R1. We configure as a network point to point, since as we know the default network type whenever you just configure a router to be an in an OSPF domain is a broadcast type. So in order for us to force the two routers to be on point to point and about to have um, the broadcast operation, we have to configure them on both ends. So you can see it right here. I also, as well on this router one, and I advertise both the internal router and the internal subnet just to, simulate a real subnet and host subnet, and of course the point-to-point connection, right? And we have the wildcard mask right here, both in area one, and so. And now going to, it can be also in a router two and a router three, but since router three is completely in area zero, we can actually see one of the routers that is a backbone router basically, and their associations with their neighbor, with their OSPF neighbors, right? We can see right here how they will be able to form a full adjacency with the designated router and the backup designated router, and we can see that this one will remain a two, it will remain a router, same as its neighbor that is with this loopback identifier, which is router 2. As I decided to identify each router, use each router ID based on each loopback address that I have assigned to each router based on their host name, right? So 2 will be 2.2.2, and so on. For the 4 it will be router 4, etc. So we can check the configuration right here. We can see that we did the same thing. We advertise the broadcast link type facing the other, OSPF router neighbors and also the internal subnet. And, and yeah, and there will be similarly to the other routers on the same, broadcast domain. And if we go to R5 and we show, the IP route, of course, we'll be able to see all these OSPF advertised subnets, but we also see the BGP advertised routes from the other AS, which is the topic that we'll talk next after talking about EIGRP on this autonomous system. We also have the EIGRP domain on this autonomous system. Pretty straightforward, really not too complex. Just using the identifier for the autonomous system as it should be, and advertising the subnets that they should be for each router, right? So for these two routers that hold end devices, of course, that I advertise, and let's find the configuration. I advertised, of course, the private subnet that has a connection with the other EIGRP neighbors, and also the internal one that it will be a public subnet that, of course, we will later use for this router to advertise it in BGP, right? For the other autonomous system to learn it. For now, yeah, let's check router 3 as well. Has the same thing, the same autonomous system identifier, the same host. In this case, I decided to use a slash, well, you can say slash 16 wildcard mask. Let's call it like that. And since, this will help us to advertise, the EIGRP and domain in both, these internal, well, both are internal, but in this subnet and this subnet as well. So that will be from EIGRP, pretty straightforward. And going to EBGP, right? We're simply just form the BGP adjacency with the other router, right? Of course, I assigned a slash 29 subnet right here instead of a slash 3 because I wanted to use some available host and for natting for this subnet, which is another exercise I wanted to do within this lab, right? So we see right here, we see adjacency with the neighbor router. We see right here the networks, the public subnets that we want to advertise from this link. And also, actually, now that I realize, I I advertised this range, but I don't remember what is the 100 range. I think the 100 range was an experimental range that I tried to do right here to not use this subnet, but to use this particular subnet for natting. But I think I ended up using this, the rest of the available host for this subnet. It works better. So I'll delete that and make sure I shouldn't make any changes. Just erase this line and just uh, have done already when I publish the YAML file to the Google Drive folder. But for now, yeah, let's check the other, VP router, and well, we can see right here already that it learned the route to, the BEP route to reach this subnet, right? And from the other OS, from the other AS. So, but let's just review the the ABP configuration as well for the adjacency and stuff. And we see right here, we use the autonomous system as identifier for BGP as well. And we, of course, set the adjacency with the other neighbor, and of course, advertise the network that we want to advertise, of course, the subnet that we want to advertise, right? And yep, so let's just verify. BGP. We have a lot of options. If you I show IPVGP right here, you can see, some stats, some basic stats about this network adjacency. We also configured, a little policy-based routing rule right here. It's experimental. It's not really made for a purpose. We just to apply the concept of it, of PBR in this lab, right? So it's just pretty simple. Just basically we create the, interesting traffic access list right here for us to, of course, you know, get, consider this subnet as an interesting traffic. We will of course create the policy map itself, assigning what will be the next hub will be basically this router right here. You can see the slash 30 will be five. I configure five on this interface and six on this one. So, and of course match, you know, match the ACL, right? For to match the interesting traffic. And so we look for the internet interface to, to the one, that we want to apply the PBR, and we apply the PBR mapping and on this one right here. So for whenever we receive a a packet from source of this subnet right here, we instead of just forwarding it, in the case that the metric is a good one, forwarding it into this path, we directly just push it into this path right here. Maybe it's destined to this subnet or whatever. But basically, will be like that. Okay, so now let's take a look at the natting and padding for each network. So let's start with the OSPF domain. And so we apply padding right here. And as you can see, of course, we created an access list first, of course, to match the traffic to be padded, right? So it's gonna be this ACL right here, and the ACL should be here. So we will be matching every host from this private subnet to be basically padded and overloaded basically. So it will be a NAT overload over this, public IP. So basically what it will do is that it will open, a port that will mean every single connection, from this, basically this um, private network, right? Private subnet. So every time one host right here want to communicate over the internet, or over the EVP link right here to this autonomous system, uh, this router will open a port on this interface, and that will be, what we will represent each host from this private subnet basically. And yeah, you can see it right here. Feel free to check it out. And also in the EIGRP domain, we're gonna be natting, not padding. And similarly, but in this instance, we're gonna create a dedicated NAT pool, right, for the translated private addresses to public addresses. In this instance, I actually left the last three usable hosts for this subnet to be, the pool of this private subnet to be natted over the EVP link, right? So you can see right here, I created an access list to match, the source traffic from this private subnet, and I created a pool to be that host range that I was mentioning, and and also of course we created the NAT rule itself, right? Also, don't forget to note that of course in both the scenarios, either in the add or in the adding. And I, of course, well, I specify, and you have to specify which will be the interface that will be the outside facing one and the inside facing one, right? Okay, so now we're gonna test the connectivity for each of the hosts on each autonomous system. So the way that we'll do it is that we'll try to make two probes, right? Two ICMP probes from each of the autonomous systems. So we'll try from this host right here, we'll try to reach this host. Remember, it has a public IP on it. It's the one that we are advertise or the EBGP link. So we should be able to reach it. And the other host, the other IP that we'll try to ping, it will be a private one, right? Just like this one. So not 192.168.10.2, for instance. I know it's .2 because of course, I found then the subnet and I host range, well, host IP. I assigned it based on the host name of each router, right? So on this one will be .2, .1, .3. So the other one, the IP that we are going to try to reach is going to be basically this interface right here. So let's begin with the private one. I actually have it right here, the public one. I'm sorry, the one I have right here. You can see we can reach it with no issues. We're getting replies. And now let's try that private one. We shouldn't be able to reach it. Let's check. And you can see right here, maybe it's resolving, but even though because usually when you can indeed reach a destination, maybe doesn't reply at the first ICMP pros because basically the ARP is resolving, it's being resolved, so it replies after. But you can see right here we're not getting response at all. It's quite of a timeout that we're getting. So let's move on. We know that it won't reply, and let's just actually test out. Let's try to, even though we can of course ping this host, we should be able to ping of course this interface, right? We just want to make sure. And everything should be worked properly. So you see that right here, perfect, no issues. And let's try the same thing now with this host. We will try to reach this host with the public IP right here that has been, of course, advertised over the EVGP link. And then we'll try to, let's try to reach this private host right here, this private IP right here for this router. So we'll first try to ping 198.18.1.2, right? That's gonna be the host for the host IP for this virtual machine. So you can see that we can reach it, and let's try now to reach that private IP. Make sure that we don't have any private leaking or something going on, right? Now we wait 5 seconds. We don't get anything, as you can see, and at this point we can now cut it. So, so for now, I will just wanted to basically demonstrate a little, summary of the lab. You are free, of course, to check it out by yourself by, of course, downloading and importing the YAML file on your to your Cisco Modern Lab software, right? And yeah, it wasn't a video to go really, on in deep over the topics, but rather that to show you how basically this lab has been configured and how you can play with it or nothing without saying nothing else. And I think that's it. And thank you so much.